All right, family, we back at it again. Today is April 5th, 3:38 p.m. It's a rainy Saturday, perfect for coding vibes. On some lo-fi music and do this with me. So let's get into it. Today we're doing number 202, happy numbers. Right now outside of this, I am at chapter 13 on this website, uh, unscoped enumerations. What I'm trying to do is really get to this part, and then I can start doing my DSNA course. I actually get into the pointers, the arrays, data structures, etc., etc. So let's get into it. As usual, 1 hour time limit. If I don't get it, then solutions it is. I think 1 hour is too long, to be honest. Let's say like 20 minutes. Like I'll give myself until 4 p.m. Okay. Write an algorithm to determine if a number n is happy. A happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits. Okay, repeat the process until the number equals 1, where it will stay, or it loops endlessly in the cycle, which does not include 1. Okay, those numbers for which this process ends in 1 are happy. Return true. Okay, input 19. 1 squared plus 9 squared equals 82. 8 squared plus 2 squared equals 68. Okay, let's see. So let's say I give it a random number, like 24. Okay, what will happen here? So 2 times 2 equals to 4, right? Plus 16. This will become 20, and then 20, it will become false. Okay, 16. So like 16. Some test cases, plus 36. That will equals to 37, and that will equals to 9, plus 7 times 7 is 49. That will equals to 58. That will equals to 989, right? 9 plus 49, 58. 25 plus 64 is 89. 64 plus 81 equals to 145, right? Plus 16 plus 25 equals to, what is it? What is it? 42, I think, right? Yep, 42. That will equals to 16 plus 4. That will equals to 20, and that will be false. Okay. Okay. Interesting. Hmm. What is the technique here? Okay, what if it's an even number? What if it's an odd number, right? Let's say 13. So there's a 1 plus 9. That would be 10. That'll be true. Right? What if it's like 67? That'll be 36 plus 49. That'll be 85. That will be 64 plus 25 equals to 89. 89 we did here, and that will become false. Okay, so it's not about the odd or even of it, the oddness or the evenness of the number, right? because we've done an even one, which is false, and an odd one, which is false, and odd one, which is true. So it's not really about the odd and even of it. So what is it about? Um, so odd is true. Odd even is false. Odd even is false. Even is false. Let's see if it's odd. Let's say if it's 79, right? So this would be 81, which would be 130. This would be 1 plus 9, which would be 10, which would be true. Okay, I think we're getting somewhere. Let's say, so I hypothesize this to not work, right? Because it's odd and even. So there should be 4 plus 9. That would be 13, right? That would be 13. 1 plus 9. Okay, so it does work. Okay, so it's not. Okay. Mm, what is the trick here? 嗯，and if it's a three-digit number, 1 plus 6 plus 8. The end of 1 equals to 1, end of 2 equals to 4, the end of 3 equals to 9, end of 4 equals to 6, end of 5 equals to 5, end of 6 equals to 6, end of 7 equals to 9, end of 8 equals to 4, end of 9 equals to 1, and 0 is just 0, so it doesn't matter. 1, 4, 1, 4, 5, 6, and 9. I really have no clue, to be honest. Um, mm, what do the individual numbers become? 1 plus 36, 9 plus 49, 58, and then we did this, right? 58. So 2 itself becomes false. Eighty-one, 65, 36 plus 25, 61, 1, 37, 37 false. Okay. And then 6, 36, 9 plus 36 would be 45. 16 plus 25 would be 41. 16, 17, 50, 25, 4 plus 25, 29, 4 plus 81, 85, 85 we've seen before, false. 25, 25 plus 4, 29, 29 we've seen, false. 36, we've seen, false. Mhm. So, what the fuck? What is this supposed to mean, though? What is this supposed to mean, though? So whichever number that ends with 9, let's say like 39, I don't think it works, right? 39, 39, 81. equals to 90, 81, and that becomes 64, that becomes 65, and that becomes false. So what really is the trick here? What the fuck? Okay, what if we just go like, we just cast it to a string view first, right? This will be like, does that work? And then the first character of the string, I can't really think of a smart way, so I'm just gonna code the whole thing out. Like just coding this logic, I'll try. Um, okay, and then while result is not true, while result is not equals to 1, and if it is, you return true. And if result equals to 2, then you return false. And if it's not equals to 2, then for n I equals to 0, and then n is less than string dot length, and then plus plus I, what you do here is you cast it back to an int, um, string I, uh, and multiply it. Um, right? So what this is This should be result. Result should be equals to 0. No, result should be equals to n first. Okay, and then result. Hello. OK，
要 coffee 係咪 Pacific Coffee？
我唔使，thank you。
好啦，
OK，
拜拜。
right. Result equals to first. Okay, result should just be equals to 0, I guess. And then result is plus equals to all the characters squared, right? Right, makes sense. Does it matter if I put it before or after? I don't think it matters, right? Um, yeah, yeah. Hmm. Underscore view. Right. Okay. Um, okay, so this doesn't work. This has to be a mod thing, right? To get the digit. Oh my God, I actually don't know how to do this. Is there a hint? Is there a hint? I don't know. I genuinely don't know. I have no clue where to start. I'm just gonna look at the solution. Okay. All right. Okay, using remainder and two pointers. Okay, if I point at the first one, point at the second one. Sure. Uh-huh. Yeah. Okay, sure. But what if it's three digits, right? What if it's a hell of digits? Mm-hmm. Why do they have a private? Okay, I feel like I genuinely don't know how to do this, so I'm not even gonna attempt it. Like, I'm gonna find another question. Um, this is as real as it gets, my friends. Okay, I don't know. Add binary, I guess. What is this? Given two binary strings, return their sum as a binary string. It's 1 0 1 0 1 1 0 1 0 1. Okay. I don't know how to deal with strings, man. Strings in C++ is so like annoying. Oh, shoot, bruh. What is power of two? Okay, this seems easy. Given an integer n, return true if it is a power of two. Otherwise, return false. An integer n is power of two if there exists an integer x such that n equals to 2x. Mm-hmm. Okay. Okay. Sure. Can I solve without loops or recursion? Well, n can only be so big, right? Um, for in I equals to 0, right? I less than 32. If how to I equals to n, then return true. Else, return false. Right. How is int, I mean, it's an equals, I think. No, less than, because it's only 2031, right? Yeah, I think so. Does it work? It does work. Okay. Yo. Oh, sure. 好啊，我真係啊，好啊。Without loops or recursion. Okay, this is my quota for the day. Like, okay, without quotes, loops, and recursion. Huh. Mm-hmm. Okay. Um, it's bit manipulation. So if n, wow, pretty crazy actually. Mm-hmm. 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 Okay, sure. return n bigger than zero and not n and n minus one. What does that mean? N and n minus one. Mm-hmm. So it should be all ones. Okay. Wow, that's very smart. Okay. Uh-huh. And as long as all ones, and then there's a power event's only one one. So n and n minus one, meaning mhm, n and n minus one. What does that evaluate to? So I'm comparing 0 to 1, and then 1 by itself. Comparing bits of different length. Hmm. What? I don't really get it. This one makes no sense, right? Push to the least significant side. Right. Okay. So it is this. Okay. So in this case, yeah. So there, it's comparing 0, 1, 1. Okay. Yeah. That makes sense. That makes the most sense. So it has to be 0. Okay. So, and not, yeah. So if it is true, then it would just be false. So it would just be 0, right? Hmm. Mm, amazing. We need to explain that if n is not a power of 2, then n and n minus 1 will not equals to 0. If m is not a power of 2, then binary string contains more than one 1. Mm-hmm. Mm-hmm. 1 and 1 0 0. Yep. Amazing. Absolutely amazing. Oops. Amazing. Why it's so slow though? Okay. I mean, well, okay. That is my code for the day. It is what it is. Gotta improve. All right, peace.